You should have a button on your keyboard that does that.
And we're recording.
Way, I'm on record now. I can't say anything. So anyway, this is not the first time we talked about security. I am sure we will have more talks of that because in a moment you will see that it's not a single topic. SELinux is just one of many security modules that we have. And whether you use it or not, I'm going to try to convince you that it makes no sense, even as a hardware user, not to use it, particularly when it works out of the box. Right. So we'll talk a little bit about why do we need to bother, because it used to be a very common question, like why do I need to secure it? Why do I need to do anything? And I'll have some arguments against that. We can really also talk about why do I even bother with security if I'm just on the home server? Why does it matter? Why shouldn't I just be root for everything I do?
But Peter, SELinux is scary.
Yeah, I know. That's why we have a coloring book for today. So we will actually use the coloring book for part of this. So those are in the room, you will see it on the screen, so that won't be a problem. But you can download it, and I actually thought I had paper copies, and I even thought I was smart because I have 2 little grandkids at home right now, and I wanted them to color it before I got here. But turns out I didn't have it. You couldn't get copies in time. So anyway, we'll cover the common commands, and I will actually go through how to set up SELinux from scratch when you do your own code and how that works. So you get a little bit of insight to, it's not really that complicated anymore, but you still need to understand what goes on underneath the covers. FYI, I'm using Fedora because that's the platform I'm used to. SELinux is on a ton of distributions, and SUSE is getting there. It's been on Fedora almost since the introduction 15-some plus years ago. If you were around back then, you will probably remember some of the brouhaha around getting it up and running on the initial versions. We are so far away from that reality that if that's what you think SELinux is, just based on what happened that many years ago, you may want to take a look at it again. But everything I talk about here is going to be true for anything that some people label Red Hat. So CentOS, Rocky Linux, Alma, RHEL, Fedora, et cetera, et cetera. So when I talk about what packages to install and tooling to use, all that will be the same. Other distributions may vary a small bit if they support SELinux. But I know some of them that just claim they have the package, but they don't install it by default, which going to make it very, very hard to install. So, need to have everyone stand up. I'm going to do the Daniel. Please stand up. Yeah, please. Yeah,
I'm standing.
So, please repeat after me. Yeah. SELinux is a labeling system.
SELinux is a labeling system.
Every process has a label.
Every process has a label.
Every file, directory, system object has a label.
Every file, directory, system object has a label.
Policy rules control access between label processes and label objects.
Policy rules control access between label processes and label objects.
The kernel enforces the rules. Yeah. Thank you very much. That is SELinux. Like, it is not anything beyond that. Like, there's no real kryptonite going on or secret sauce going on.
Yes, except there's 100 billion processes and 100 billion objects to consider.
That's right.
You know,
Well, remember, you're running a system that has multiple processes on it, right? That's the whole point, is that you want to protect each process, and I'll get to that in a second, from stuff that you don't know about. You get an update, and all of a sudden it has a new behavior. Or you download something with curl and overwrite the binary, and it wants to do something else. SELinux is there to stop that. Right? So why bother with security? So as a home user, I remember in the 90s when I started Linux, I really hated having to deal with, chmod, setting up a user. It was just like I logged in right on terminal to root and just did my stuff. I have the scar to show what happens from that. right? Because it takes one typo, and you do an IMFS, and you have a / because you want to do the full path, and you accidentally hit the space, and then you type the rest, and your system is hosted. That was before it says, are you really, really sure? Something else can happen, right? You might go and think that you configure things to do in a certain way, but your web server keeps stopping, it keeps being blocked from running, and you realize it was going to serve out files that might have been your private pictures, or where we keep your letters that you won't want to share with the world, and it was not allowed to get access to those. Now, if I'm root and I have nothing else, there's nothing stopping that from happening. But because it's a labeling system, only the files that are able to be allowed to be used by the website or web server is going to be allowed for the web server daemon to load. It can't see anything else. And that's why we need SELinux, because we need something to sort of check on us between the application, what it wants to do, and what we think it's going to do. So when things happen that we were not aware of, and very often that could be, I'm going to enable, again, I'm going to keep the web server example. I'm going to enable a CGI bin so I can run executables as a part of my website. But I made a boo-boo, and someone got write access to that directory, and now they want to do crypto mining. They want to use my GPU or whatever. If they have write access to that file, let's say that was a bug, with SELinux, that executable will not run, because it's going to try to do things that the web server is not allowed to do. The web server is not allowed to go in and look at what devices on the system. Why would it ever need to do that? Why would it ever need to be able to create a file system or anything else beyond that? So what SELinux simply says is, you can go to these files only, and you can only do X with them. Right? So if you're running a binary, those are covered by the same process that the web server is. And hence, it gets blocked. And that's unfortunately how some people say, well, I'm installing this weird thing, let's say a WordPress thing, and it needs to be able to run new processes and services. And you can't understand why your system doesn't work, because it keeps killing the processes. And that's why. Because generally speaking, we don't want a web server to have that right. Now, can you change that? Heck yeah. But now you have to think about, is that really a good thing? Why would that be a good pattern to use? But within the Linux in general, we have a lot of security systems. So you could also ask yourself, why do I need, when I have all that other stuff, why do I need SELinux? Does anyone here not know any of these things that I've listed up here? This is not a complete list. That was just what I could remember right on top of my head. Right, so we have, everyone has, when Unix came around, we had chmod and umask and all that stuff for files. Who here does chmod 777 on your files?
Sometimes.
In production, right? Only in production, right?
I never use, it's weird how other people get used to using numbers. I don't ever use numbers. I usually use,
Right. Well, then plus, read, write, execute, and everything. Right?
Well, not everything. Not A plus.
Yeah, A plus, yeah, read, write, W, right? Yeah. So I usually use that example of saying you are using security already, right? You just think that that's enough. Right? You are going in and saying, well, I have a user over here that can only see these files. I have a user over here that can only see those files. I have a daemon, it has its own file. What we are just trying to do is to ensure that we have a security pattern that matches the threats that are out there. And chmod is nice, but it's just one of a billion ways of securing the system. So you might not know if the file attribute is an interesting thing that I think is almost forgotten. But yeah, remember, this is one of my early lessons learned, is what happens when you make an immutable file, which is what file attributes can do, the extent attributes can do. If you've never done that and gotten a ticket on someone say, I'm root, I can't delete this file. I see them still. And that's because the file has been marked as immutable.
So will you explain the difference between, let's say I don't use SELinux, but I just use namespaces?
Uh-huh.
Allowing to do why is one better?
So they're not better, right? Containers use both namespaces and SELinux,
Yeah.
right? Namespace is a way of limiting what you can see in the system. Right? So it gives you a smaller subset, or the whole subset, of what the system has from process IDs, IP addresses or NICs, anything that is a resource on your system, and namespace can basically say your world looks like this. So that's why when you go inside a container and you say PS, you see the first process is PID1. You go outside the container to a PS, that process that is the container is not called PID1. That's what the namespace does. But inside the container, I see maybe 2 processes, 3 processes right now. But the host might have 150. So by that alone, you can't see anything else what's running and start, poking around to see if you can do some damage. Is it denying you access? Does it contain an audit of what you tried? Hell no. That's not what it's there for. But to me, not giving access to even view things that you have no access to is a good beginning. Now, if you are on Fedora and you're running with systemd, which comes with default, you are actually in the namespace with everything you do. Part of what is systemd makes very, very easy is that namespace definitions, C groups, and a few other things are defined by default. Now, by default, your end user is going to be able to have a namespace that covers everything, more or less. But you can go and very easily change that and say, well, when you log in, you only get X to view. Now, that doesn't necessarily mean that I have access to it. Just because the namespace says that this is your pretend device for this device doesn't mean the underlying system does. What SELinux does is to say, can you actually use these devices? Are you allowed to use this NIC? Are you allowed as a user to open this, start this process? Are you allowed as this user to view this file or access this file? And or is this process allowed to do that based on whatever context it has? Right. So we'll go in a second to the comment book to explain what that is. But we have PAM. How many have done customized PAM rules in the past? Yeah, someone else has scars for that. Yeah, all right. It's a very intricate and it's a very old system of how to define security. And the cool thing about PAM is it makes it so I don't have to have rules inside my code that says, well, am I allowed to do X, Y, and Z? Because now in PAM, I can define the nitty-gritty rules about how do I authenticate? How do I get an ID? What is needed for me to be able to be a valid user or not? And I can modify that. HoloKit is sort of in the same idea, but it's more or less mostly using Google. So when you go in and you add a printer to your favorite Linux distribution, and it doesn't ask you for a root password, but it does that. That's because of HoloKit, allowing end users to create printers. It can do other things too. It can, basically act as your sudo if you really, really want to. And it's just a policy linker that runs side by side with what you do, and uses dbus to communicate back to your GUI and your kind of your home controller. Could we do that without it? Well, for a long, long time we couldn't. And I still remember, this is more than 10 years ago, there was a very angry, famous Linux outburst when his daughter went to college. And she called him up, Mr. Geek, because she needed to access the college printer and she had to have the root password because Daddy hadn't given her. And he went irate in a minute. Why the hell is Linux requiring admin rights to just add a certain printer? Right. To him, that's not a security thing. And less than a year later, all the pockets and information out there allow you to do that. And you know what? Now, if you go behind the scenes and look at some details in COPS, you still need root access. But just to add a printer, literally, if it's on, okay.
A couple months ago, there was like a big touch vulnerability actually that kind of exploits the fact that network printers kind of get automatically added, and then it runs the configuration script for them.
Yep. It's so one of the cool things is if you're using a body, which at least is on Fedora installed by default, and it sees a printer. When you go in and you say, I want to print, it sends out, tell me about all the printers on the network, and it gets those. And because most printers today, you can get the PPT, and the PPTs, by the way, is being deprecated, which is very sad for me because I used to do a lot of those. But that comes out in line. But you no longer need, in order to tell CUP that you have a printer that you want to add, root rights. And that's on purpose. Now, do you want it to just start doing other stuff than just tell you the printer's available? Hell no. Right. And you can turn it off. You can go into the policy kit and say, no, I will not allow that. My user should not be able to do that. But who here has multi-user systems where you, more than just you log into it? Right. So for most cases, we're talking about, well, why do I care? I'm the only one. But if you plug in a printer and a USB cable, it will also just say, oh, I found the printer. Here it is. And again, if you don't really think about it and you take it for granted, that could be considered a vulnerability. I have a problem with a good portion of the CVEs claiming they're high vulnerabilities, and they're not. That said, you know, when we literally have press releases about bugs that are so theoretically they could really know what happened. Like you have to have 1 foot on the ground and another one in the lake, and then you have to hit the right key at the same time and hope the OS is 10 years old, and then you can get it. Or something like that. Like,
it's the branding of the CVEs.
Yeah.
It's like everyone from has had its own brand.
well, it doesn't help too that some companies have rewards that gives you if you find bugs in their code. Right, so there is an incentive out there for people to say, well, I could show them something that looks very complicated, and it is, but could really never be made vulnerable. I mean, even at work, both Ted and I, have customers of Red Hat sometimes talking about, we find all these CVEs and we want to cover it. Right? Explaining, one, that the version number they think they're running in Red Hat is not the same as that version number. One as an issue. But even when we show them that, well, we don't consider this a high issue because anyone using RHEL will by default be protected from this. At worst, the code stops, the web server will start running. Is a system being restarted automatically after that. So you're not really having an outage or a vulnerability that allows someone to go in and grab all the data on your server. So the CVE is not a high urgent whatever. It gets lower to say, yeah, we should. It's a bug. We're going to fix it, but it's not a high risk CVE. Unfortunately, the label makes people go, wow, this is a big bug, right? And it makes the press and they have no clue what they're talking about. SELinux has saved Red Hat customers a lot with this.
No, and I've just tried finding the statistics on it, but they come up with anything Google. But the majority of vulnerabilities that you see now are all file based, right?
Yep.
So if somebody gets access to a file that they shouldn't have access to, and now they can change some information, like maybe a password that's embedded in the file, which is a terrible thing. And all of a sudden they have elevated privileges for some system or some services running in the box. SELinux is awesome at blocking file level access.
Yep.
So if you think about it, the majority of vulnerabilities are file-based. SELinux.
I'm going to show why it's a lot more than that. Yes,
Okay.
Anyway, another feature that
It's usually what gets in the way of me trying to start SSH, because I'm not really familiar with Red Hat type stuff, and every time I try to do that, and it's like you can't. I usually like to change the port to SSH.
So I will show you how to get how you will fix that. Like this is it's one command. So that's another thing. The SELinux got resources like what ports are allowed. Even though you're root, it will stop root from doing things.
Right.
Remember, out of the box, because we found out that if we secure the box too much, users get angry. Because people think that if I'm root, I should have access to everything, which is legacy. When I prepared for this talk, I went through some archives, and it turns out in kernel 2.6, we've been around Linux for a while, that's a very famous number, was the first time we stopped having code in the kernel that says, if your user ID 0, ignore all the conditions. It changed in 2.6 to basically saying, you have to have this capability in order to do this. And unfortunately, we just basically made it backwards compatible by saying root has all the capabilities. So it's not really being protected. The result is the same, But I can change that. I can go in and say root no longer has all the capabilities, and presto, root might not even be able to make a directory in his own directory anymore.
It's a lot of layers.
Yeah, but the idea again is you should not. I hate being root on a system. I'll do sudo anytime if I need to, but having that hash prompt is kind of scary these days because I know I've been screwed up by my own mistakes before, so I try not to. But anyway, there's another thing up here that I want to be sure I mention. FA policy B. How many here knows about that?
Oh, I do.
Well, yeah, I don't count you. Okay. So I've only seen people that is on Red Hat infrastructure and talk about that, or even use it like. So to me, it is almost sort of in the same sense a part of what SELinux does, but it goes one step further. So one of the things that I found very interesting when I look at that is to say, well, that would be an easy way of hacking. So most times when you want a command, you write the short version, just the binary, right? So ls, and then you do the thing, right? And there's a path that it goes through to figure out where the ls command is. Well, what happens if someone on my box puts ls in the home process bin? Which ls is it going to execute? It's going to execute the one on my system, in my home directory. Very short, what FA policy D does is to ensure that I will only run the official version. So if I put in as ls somewhere else, it will not touch them. Or if someone modifies the ls program where it is, which requires root access, it will also refuse to run it because it doesn't match the signature. And that was something I never really thought of until I saw that come around, is that was actually a very easy hack to get into a system. I was just basically putting in binaries that mimic existing binaries that everyone uses. So if you have not enabled it, and you have it, and you have a server in production, even though SELinux will stop some of it, it will not stop that one, because all I have to do is make sure is that the file is labeled correctly. And then it'll be happy. And if you have the access to do that, you most likely have the access to change the label on that file. So I talked a little bit about why not being root already. I talked about capabilities. So we talked about namespaces, and then now, of course, now we have SELinux. So we'll go into that. I tried to pronounce that last night, and I was not sure what. But there's an old saying, but who watches the watcher? It's so old, we have a Latin expression for it. To me, when we talk about SELinux, that's really what we're trying to do. Right? I don't want to have a trust to say, well, you give me a binary, I know who you are. You're not going to do anything bad. We have seen so many supply chain hacks these days that someone that's been on a project upstream for years, all of a sudden now they're giving away their credentials to someone bad because they need money or do something else. That puts very bad stuff upstream. Right? And if you just basically have that trust model and say, well, I know that source, I've used it for 5 years, it is not going to do something bad. We have now been shown many, many times that that's a bad trust model. Because things can happen. So we need to basically ensure that we don't have that built in to the beginning. So that's when I look at SELinux, because that's all separate from the code that is running. I can ensure the same rules are there. So if they try to do stuff they're not supposed to, like open URLs or whatever, that for something that was never supposed to be online, that it will be stopped. Right. Another thing that I like, so even if I use PAM, I have to do a call out to say, I want to execute this PAM policy. You don't know what's in it, but you're going to say, this is the login, this is how I authenticate, this is how I get access to all the hosts or whatever I want to do on the network. But SELinux, I don't put anything in because it's the same kernel commands that I already have to open up a file or open up a port on the system. And the kernel is what does the validation. I don't have to create another API. So my code, more or less, will never have a clue about SELinux at all. I can basically go behind the scenes, behind the shoulders of that code and tell it, well, you're confined to just do this. and I don't have to change the code at all. That to me is a big plus. Right? Doesn't mean it's always easy, but it's a big plus that I don't have to go upstream and have them fix the bug. I can at least block that code from doing bad stuff, or what I consider bad stuff. And of course, it means that, again, the developer who might not have good intention can go in and basically allow features that you should. Now, if you're allowing them to say, well, every time I install it, it needs to run a root script, and you don't monitor that, yeah. If you don't restrict root from creating policies, hint, hint, that could be a very bad thing to do. So now it's time for some coloring books. So Ted shared a better link than what I gave you here that is on a GitHub, and these are free books. But when you put it on the official Red Hat site, it's now requiring you to use the free account that most people have. But anyway, so I pulled it up here. So the coloring book came out of two very impressive people that works at Red Hat. Dan Walsh, which you should know, used to be called Mr. SELinux. Now he's Mr. Container. He's a distinguished senior developer or something like that. He literally created SELinux. Right? When NSA created the first version of SELinux, they basically ran into a wall and said, this is not working for us. We need MLS, we need all this advanced stuff, and we're stuck. So I wasn't a new company, but a company that went through enterprise IT with Linux. They went to Red Hat and said, can you guys help us? And we did. And when we say we mean Dan. Literally created the foundations of what SELinux was. And I think most of the conversations that I remember about it was made by him. He has some excellent Red Hat Summit talks that makes SELinux look like it's nothing at all, and very fun, actually. But if you ever have a technical question on a forum where he's on the Fedora forums, by the way, he is the right guy to ask. And I typically try to use the royal word we when I talk about work. When you listen to Dan Walsh talk, he says I. And that's simply because that is the truth. When I made it, when I thought of this is the way it was supposed to work. And this is why I think this is a better solution. He's been through that whole thing. And it's amazing when you look at that one person could create that.
He's been behind stuff like Hotman.
Yep.
Anything container security related.
Build up.
Build up. Yeah.
Which is based on how he pronounces it. Yep.
I mentioned Ramalama earlier. He's behind Ramalama.
He's a very fun guy.
And then there's some other internal stuff they do.
Yep.
It's incredible.
Yep.
And if you go to, well, at least when they still had that office. If you went to the office I worked at, he had a window set. His back was to the window instead of looking out. And if he was there, you'd be like, "Hey, Dan, I'm going for lunch," and he was always willing to do that. I actually took him to In-N-Out Burger once. Yeah,
really? He's a very
fit him in Texas for a customer. We were like, "Hey, want to get a burger with us?"
Yeah.
It was like
I grew up there. They didn't have that.
Yeah, I've been to meetings where he talks. I mean, he's an engineer through and through. He can literally talk to every level of the organization about stuff. It is so rare to watch him.
They love fast food burger because everybody else in fixed mouth takes them like 4-star restaurant or some fancy places that can charge fancy food. Like the burger's awesome.
Yep.
Well, it was like this. Gordon Ramsay loves In-N-Out too.
Yeah, so they're building like 15 In-N-Out burgers in Tennessee. Yeah, along with the distribution warehouse. And they moved their headquarters to Tennessee as well. They moved out of California.
Right. Yeah. And the other person, Marion Duffy, or Mo, as she wants to be called, because no one can pronounce her Irish name, did all the decorations. She is very active even on the Fedora side, making sure all the graphics, all the artistry is done. So she's not the technical person that created the code. She can do some of it, but she can make it look pretty damn cool.
And she's in charge of Instruct that.
Yep. So those are two very big names that got together to basically come up with a new way of looking at it. And I've, since this book came out, the coloring book, I have seen, well, we have a container book too, and we have a few other things like that, but other organizations have copied this approach because, well, as we will see, making SELinux work is something that a 5-year-old can do because they can just color this, right? So some of this is going to be a repeat of your pledge earlier, right? But so SELinux can be considered a type enforcement. Remember, everything is a label and basically determines what type things is. And the rule says what types can this process work with. Right. So we have, in this case here, we have a cat and a dog. And those are we are calling process types. Right. So there's two different things running on your system. They're just called cats and dogs. Right. And we have some objects, which is we have cat chow and dog chow. And the whole idea here is that we want to make some rules that will only makes the cat eat the cat food and the dog eat the dog food. Right. So we need to basically be able to say, well, as long as they're doing that, yay, the cat are happy, right? And the same with the dog. But sometimes the dog's extra hungry and wants to eat the cat food.
And if you notice, there was, if you scroll up a little bit, Peter, the slide, page 5. One more. You see, eat's a verb, right? So instead of eat, when you're talking about files, it could be write,
Execute,
open, it could be
execute.
list,
Yep.
right?
Yep.
It's verbs.
That's
So-
verbs, right? What can you do with it? What now? That's the file side, right? When we talk supports, it's a little bit different. But anyway, there is a verb involved. Like this things can do that thing with this type.
You can do write, but not read.
You can overwrite stuff, yeah, but append would not be possible without read. Right. So again, so what we see here is because this is a kernel enforcement, right? We don't have a process running on the system like certain other solutions do that tries to figure out what is the system trying to do and then interact. The kernel literally says this kernel call looks up in the policy compile rules that is in the kernel, and if it doesn't see a pass, they will deny it. Now, part of the problem is, and what I realized that people don't really like about security is when it comes to being on the outside of a fortress that wants to get in, the people inside that fortress are not going to tell you what you did wrong. It's kind of like when you want to log in with username and password and it just says doesn't exist. It doesn't say, well, this user's password is not what you entered. It just says username and password are wrong, but they don't match. The same as SELinux, right?
Well, sorry, but I mean, like, the default of deny is, it's the same in network firewalls. Any same firewall starts off with default deny, and then you open up what you do. You don't go the other way around.
Well, so that I would say that most firewalls that I've set up will not use the reject as a, but it will basically not tell the opposite party that it was blocked, unless you're doing internally and you want to be nice to those, but any external calls coming in, you let them time out. Even better, you may give them on some runarounds that takes them even longer. So from a security perspective, it's important that we don't necessarily let the adversary know what we're up to and what we're doing. So when the kernel says no access, that's all you're going to get. So if I'm trying to open a file, like I don't, or eat my dog food, it's just going to say no. You're not going to say why. And that typically means people go, what then? What do I do? What happened? Why can't I not do this? Let me illustrate why you're already fixing those kind of problems. Just using chmod as an example. Like, let's say you create a project directory in your home directory, and then underneath that you have each project. Underneath that you have a source directory. You might have your target testing and all that, and you might underneath those have artifacts like images and other things that you want by your organization. Pretty big hierarchy. But you make a mistake when you create that project. Sorry, at some point after you did that, something happened to one automation and you removed the execution bit on the project directory in the home directory. And all of a sudden, you can't access anything in that directory. You don't know why. The argument is root, and you can see some stuff, but you can root if you don't put it on world, don't see that. But how do you figure out that some directory in your path is blocking your access to that subdirectory? And it's just a little X somewhere that you may not even consider. Right? And particularly if you're using ACL, you have the same problem because there's a lot of different rules that could be applied. And you don't necessarily know how you ended up unless you know the tools to check that. So you're already in a system, even before it's a Linux, that don't really give you a lot of hints to where things are failing. And that's on purpose. Right? I told you, those cameras do not work with me. I know what it is.
It's just one that off to the side. All right. 100%.
As long as it gets that, it's fine. I can go in here and like, hello.
Yes. Okay.
It doesn't like me. I told you, they don't like me, those cameras.
It's actually fine. I think he's trying to do something.
So they have several new versions. I looked at it and I go, yeah. Anyway. So that's the basics of it, right? That this is literally what we do. We say we have cats, we have dogs, we have food, and we have some actions with that food. And we're going to tell what's allowed. Now, SELinux is kind of funny because the moment you start labeling things, the default is denied. You have to tell it what is allowed, not what is denied. If you don't tell it it's allowed, it is going to be denied automatically. Now, there are ways of telling it to deny explicitly if you say, I want to allow everything here except for this one rule, right? That might be one way of looking at it. But most often, all you want to look at is allowing things. So we can look at the general rules enforcement here, right? We say, well, what happens if we have dog food for more than one dog? And we want to do the same thing, right? So we not only have cats and dogs, but we have different dogs and different cats. And we want each of those to be treated differently, right? So as Dan says here, one option is to basically create a ton of types, but that would be kind of amazingly hard to implement. So what we do is to use the multi-category security, which is what this is about. We basically say that this overarching category has all these subforms. And the subform will then augment what needs to be different from the higher ones. But if it doesn't say anything, it's the same thing. Oops. Right. So in this case here, one thing that's weird for me is that they choose to use the word random instead of giving them a real name, but that's okay. Right. So, oops. So we label now a specific dog, random 1, and another specific dog, random 2. And it's basically just a colon between them.
I think what you was trying to get at there is how it actually chooses the random category labels.
That might be what he's trying to deal with, is the C's, C in the numbers and all that stuff, right? But for kids, they all want to give them names. That's the first thing they always do, is give things names. But anyway, right? So we can now do the type enforcement, and we can now ensure that the cat chow can only be read by the right subcategory of dogs. So the random 1 is allowed to eat it, but not just a dog without a subcategory. And we can do the same thing if it tries to read get to the wrong food. As you can see here, this is the random 2. It's not allowed to, only random 1. And I'm really not going to go into MLS unless some of you guys are within the military. I bet you're not even doing this at work. Right? But there's a small section here that basically goes down to what we can do is to make a hierarchy. So we can have someone on the top that can go down as far down as they want, but they will also on the bottom can't go back up. Like it's like a hierarchy of who can do what, and if you're high enough up, you can do a lot. Still the limits, but still high up. And this is what my understanding was what the NSA wanted to make Linux be able to do, because that's the reality every day. They need to secure the systems this way. And that was part of what they were having a hard time figuring out how to implement. But I love this idea of being able to just make a simple coloring book, and you can print them out. And the principles of what SELinux does is in it. Now, remember, it doesn't show the commands. It doesn't show anything that we're going to get into in a moment. It just talks about the principles of what we do. And those principles basically have objects or processes, things that do things, and a verb that says what it is trying to do on what. And that's it. That's the three you put together every time. But we have some tooling to make that easier.
And the military way of doing things, they will refer to that as Pugula, I think. A Pugula Bell or Pugula, I can't remember what are the names here. But basically says that you can write down, right? So if you're at a higher, no, I'm sorry, you can write up and read down, right? So you can, if you're at the unclassified level, you can write things to a higher level. But if you're at the higher level, you can't write things to lower level because you might be writing something that needs to be at the higher level. But if you're at the lower level, you can write it up. So it's write up, read down, fill up, Pugula. That's how some people refer to it.
And I know an organization that does that, right? That is the reality of what they live in. Right? A lot of us, when I look at a server, I'm not really looking at, I'm looking at things that eventually will have users signed on to them, but not Linux users, right? It's other types of users. So often that's not relevant, but my applications will most likely need exactly what Ted was talking about, of how to implement it. And luckily we can do this using an IDM to implement that even on Linux. So anyway, so what we learned on the coloring book, I've always looked at SELinux as something called a mandatory access control system. Right? It's once it's there, no one, the end user, meaning the developers, cannot turn it off. Only the admin, if they're allowed, can say set enforce 0. Remember, we can take away that privilege. No one can do it. We may need to put up a special user that no one knows about that has that privilege if we need to. Making that root means that anything you run as RPM that runs a script will have the right to turn SELinux off or disable it, not turn it off. So we label everything. We have object types, policy rules, default access, and we talked about multi-level and all that stuff. So again, I will not be the one that can really do MLS justice, but I can find someone if you guys are interested. Maybe Ted works with people who can cover it better than I can. So anyway, so this is my way of doing graphics. I'm not very good at it, right? But the idea is that between us or the process that we represent here, we want to get to be allowed to eat a cake. What we basically are doing is we tell the kernel, I want to eat a cake. Right? The kernel then grabs the cake, which is the subject, and it creates the policy, makes the definition to compare, am I allowed, am I not allowed? And if I'm allowed, it gives the process the cake. If not, it says, no way. Those are the basic steps that happens, right? Now, granted, the kernel is a little bit more optimized. It doesn't read the policies every time. They're in memory, but it's there. That's literally how it does. It consults the policy rules and the subject you are looking for, the cake in this case, with a match. Yes, go ahead. So we have different types. And to Ted's point, what most people know is the file context. And that's absolutely, it's a foundational part, but it's not the only thing we have things for, right? So we have our processes. We have also SELinux context per user. We have a specific user definition that is the SELinux way of looking at the user. We have ports. So we have every port that you, basically all the numbers up to 65,536. where you can say which context does this port belong to. So you can deny access to ports that are higher up than 1024. We no longer have that artificial block, although it is simulated because, as I said, based on the changes we had in 2.6. So you could say that port 8080 should only be allowed to run on these, let's say you run HA proxy or something else, and lock that down. And I'll get into how to modify those things in a moment. But those, to me at least, are the ones that I have touched the most with SELinux. That, and I will get into in a moment what booleans are, but setting up a boolean that does a lot of things automated is kind of neat. Oh, there it is. So a lot of bugs that I've seen people, proposed bugs that I have seen has come down to a boolean that wasn't set. They don't understand, they get a deny error, and they go, well, they say it's mod 777, and I'm still not allowed to read the home directory's public HTML. I gave root access, I gave the Apache user full access to the directory, and it's still denied. And they go in and say, and even the file contexts are correct in that direction. It's all HTTP context. Why am I still denied? Well, by default, the boolean that HTTP uses for home directory access is off. It is not going to be allowed anywhere near anything in your home directory. Now, I don't think this is very common anymore. There was a time you're running a web server and you had lots of users on the system. They all got their own little directory on their home directory where they could do their own website. Pretty easy, right? If you just have dumb little files or maybe a little CGI if you like that. You could do that. You put in your own HD access and you could control who had access to your own little site and you going. I mean, most people are just used to going to Amazon or something else with their website or GitHub to make the site there, and they don't care anymore about this. However, Apache and Nginx by default are not going to be allowed to touch your home directory. You literally have to go in and find that second parameter up there and set that to true before it will be allowed to touch a user directory. It is such a common error that one of the first things that as a troubleshoot show did was to talk about what booleans you should set to allow an action that you know. So if it knows, it can see, oh, this is a typical pattern that I see. It will come out and say, hey, you should set this. If you want this to be allowed, you need to set this boolean.
So is that just like a global config option? Because that seems hyper specific. Because why would you say HTTP enable home directories instead of attaching the enable home directories to that context?
Because I can turn it on and off individually of that.
Yeah. What if you wanted something that wasn't HTTP?
So just because you set the boolean doesn't mean that your directories are set up, right? So you still have to change the context on the directory. So if me and you are on the same system and you want to serve content from your directory, you have to enable home directories and then label your directory.
Right.
Yeah, I'm just trying to figure out the difference between using this and using the labels and
All this does is enable built-in policies that are already done.
okay. So it's just like
It's like a macro you can call it.
Gotcha.
It's-
So they're not part of SELinux, they're inputs to the thing that generates the SELinux tools.
It's part of the policy engine, yes. It is what the policy engine uses. And we'll see some macros in a moment too that it can use to basically short wire a long set of policy rules in an easy way. Oops. Hello.
Yeah. So it's kind of global, but it's not, right? You're enabling it on global scale.
But it doesn't create a home directory. It doesn't set the context correct or anything else. It just says that process will be allowed if it attempts to try to open it. But if it doesn't find stuff it is allowed to access, it won't work.
Yeah, the HTTP stuff used to be part of an exam. Won't say which one because we can't talk about this yet. But it used to be part of.
It's like Fight Club.
RCSA there.
I didn't say that.
All right.
You're allowed to talk about it.
Nope.
You just can't talk about it.
Yeah, sometimes that differentiation is very hard to make, but yes. So I can do a couple examples. You guys want to see them.
Don't talk about Fight Club.
Yeah.
One of the things that the GNU utilities did for SELinux was to use the same capital D as that, or whatever language you want to use, as an indicator that you want that command to show you SELinux something. So we have it for listing files, we have it for listing processes, we have it for listing things like user context and all kinds of other funny stuff that we have out there. So it is sort of using, if you know capital Z, you know how to make a command showing the SELinux part of what that command is. If you don't put the -C, the default is to not show you any SELinux stuff at all. So if you're getting file denied, what most people start with is the first command out there, the capital -L capital C, so they can see the context on all the files. Kind of interesting to know that, again, just like with this csmod, if you're in a directory, remember all the subdirectories have to allow you access to it. So you can't just say, hey, this subdirectory here gives you access to all these files if this directory underneath it doesn't allow you to execute and go all the way up or down, depending on how you look at the tree growing out of the ceiling or the bottom. But we have a couple of key commands that I think people should be using. The chcon and the change context is what we use for files. So that's how we can, without using the policy engine, without setting up a rule that says all of these files over there should be this context, we can override whatever file we want to keep the context. It's great for testing, but warning, if you get an update, if you've done that on system file and you get an update, there's a very good chance that will be changed back. The moment you go back, or the moment the system does a relabeling of the whole system. So chcon for me is temporary. But it's temporary in a way that allows me to figure out what the heck do I need to do. Should I use this content? Should I use that? What can I do to make this work? And then when I'm done, I will have to put the policy right. Yeah, so that's what the second line shows, is how I can change or set. In this case, it's the right context, right, on the HTTP conf file. I can set it to anything I want. And if I change it to something that is not what the policy work expects, no access. And Apache will not stop if that's the case. And another one is the SE status command, which tells you whether SELinux not only is active, but what major settings it has. You can use get enforce to get just whether it's enforcing this status. It shows a little bit more than that. Let's see if I can actually get my. Okay. Okay. Right. So you get a little bit more about what's going on when you do that, and that's a great status of policy system configured. So as you can see, the local policy name is targeted. And I'm going to mention that a couple of times later. By default, the targeted policy is what's going to be installed. But as the name implies, it is not taking a complete approach to the whole system. It literally says, these are the processes that, and again, Apache is very commonly used, that I know about that I'm going to put SELinux context on. And then it's going to allow users or processes that they don't know about to have unconfined, meaning they could do whatever they please. The moment you take a process and label it, then that goes away, and then you're targeted, and that's where you get, hey, you can't do this. But if you take your own process, let's say you create your own code, which we'll do in a moment, and you, let's say, write a ton of files in your own directory, or maybe somewhere on bar. You can own your own directory on bar and start adding stuff. There's a very good chance it'll work because you are unconfined to that user or that process that you just created, that program you created. The moment you try to write something that isn't able or read something that's it's going to go, nope, you don't have access. You have to be allowed to get access to something that is marked as being part of SELinux. But if you're not using it, particularly if it's in a home directory, you do whatever you want. Okay. That may not be a good policy to have in production. My advice is always make sure you know what's running and make sure they're covered by all your policy rules. Take everything else out.
It seems to me, I'm just thinking about how the forces on the existing system maybe doesn't have SELinux installed. I was starting from scratch. like a plain server, Fedora, Debian, whatever,
Mhm.
you can turn it on, you can turn on enforce by default,
Mhm.
and then as you install stuff, see what breaks, and allow them. But the problem with an existing system, you've already got a whole bunch of stuff installed on, that, that would be difficult to manage, because you turn it on, you set, enable by default, and then you have a whole bunch of stuff that you have to go back and fix probably in order to get it to work right.
So I will show you what the process is. So there are times when we want to say permissive, not disable, but permissive mode for SELinux, because that means that I get all the errors, not just the first. Because that's literally what's going to happen. The moment you are in enforcing mode, the first rule you try to break, you get into where it says denied, it kills your process. Stop. So if it tries later on to do other things that were also going to be denied, you won't see that anymore because you never got that far. But in permissive mode, you get all the error messages, but it doesn't stop you. And that way you can make one policy using something called order to allow that covers all of them.
Yeah. Okay.
All the blocks. And by using order to allow, it basically goes and says, here's all the errors, and here's the rules that I need to add to make those errors go away.
Yeah, of course, if you've got something that's doing something that you shouldn't be doing on your system already, and you do that. then you-
Right. So that's why, if
Say
you,
again?
so if you look at the order to allow manual, it will literally say, just because you can, you should. Right. You need to look at, hey, what program am I running? Does this action make any sense? Yeah, reading a configuration file is probably a very good thing to be able to do, but opening a secret port somewhere that you were not aware of, no, that's not in the configuration file. That would be a warning file, and then I was going to use that log to say, oops, I have something wrong with that program. Let me actually not look at it as a Linux, but look at the software to see what the hell is it trying to do, and why would it ever want to do that. And sometimes you learn, you go, oh, I did not know the program had to do that to do this function. But now you know that that's an expected feature that you have. It's kind of like if you take the firewall and by default deny egress. Only allow the egress that you know of. You're going to have surprises of how much it's trying to get out of your network. And whether you like that or not, that may not be something you can control. But it's a fun little world when you actually have to tell it exactly all the operations that but we have tools to help us do that. And I'm going to show some of them here in a moment.
Would there ever be a need to hide the context, or would that even be possible?
So within namespaces, I can see the context that is on what I can see, but it doesn't mean I can change it. There are things that are under the SELinux that we'll get to in a moment that will require escalator privileges to be allowed to see what the policy does. But if it comes to a file context, no. That whatever files you can see the context of. But you may not be able to see all the booleans that exist, or depending on what kind of criteria you have. Could I imagine times? Well, the way I would look at it is, if I have normal users on a system. Remember in the olden days, we had the S-bin directory and the bin directory, and the S-bin was not allowed to anyone but you. I would not give them access to the binary to begin with, if I could. This is one of the reasons I love containers. Right? I can make a very small subset of features that is only available for that app. So even if there was no security around it, I can't find it executable. It's kind of like, I can't find the IP address command. I want to set the network. You need to do that. Okay. Why do you need access to that? Right? You're only going to shoot yourself in the foot if you try to do that from inside the container. But I can remove all the commands that has nothing to do with what that user needs to be able to do. And in that case, I would have a container where, as root or as the user who's allowed to, I can make that a privileged container with all the SELinux commands. So I can set up the policies and stuff. And then when it's gone, and no one else can see the commands as well. And that, but -C, as you see there, will always be there. So any user that logs in can do an ID -Z, what's that? And see their context. But they can't see the policies. SEManage is, to me, the big one. It has a ton, And this is not even the complete list of subcommands. So everything that can be related to OpenShift, sorry, SELinux is in there. So this is where we create rules that the system uses to guard what is in the initializer. I want to use this something a little bit down here first. Right? So here's the difference between this and the file context. The file context and chmod. chcon, sorry, it's the name. chcon changes stuff right away on the file system. That's not what f context does. It sets up a policy that says every file that matches this pattern has got this context. And then it needs another command called restorecon to apply those rules. So it's basically setting up a database of all the rules in your system. So if for some reason someone makes a chcon that he shouldn't or she shouldn't have done, restorecon is clearly all we have to do to get it back. And so it will read those policies. So sometimes you want to go in and say, well, it's a very old example, again, from a web service perspective. I want not to use var the www. That's not the directory we want to keep our web server. We want to use /www. Well, that is not in there.
So are you saying that if you do use chcon to make a change, and then if you at the context restore or whatever the command is, that'll undo that change?
Yep.
So it's like deterministic.
If it's in here, if this one says that every file in, let's say var www, whatever. I think that's the file getting old. But if you go in and change that, because that path is in f context, and I'll show you that in a moment. When you run restorecon that reads that, it will override whatever you do. Or if you do a update of an RPM, it will sometimes do the same thing. So it also means every new file that is created will look in here to see when the OS says I need to create a file. It will look at this entry to figure out what is the default context I need to get. So one of the things, again, I'm going to talk about certification you probably want to know about is how to do that guy. Because that is literally where most of your basic problems start, is to say, well, I did not want to run what Red Hat decided to be the default. I want to do it my own way. And in most cases, it's just a matter of setting the labels correctly. And if you do it by hand and nothing sees that directory elsewhere, that's fine. But remember, if you ever create a new file, it will have the one context. So it's much better to use that guy and make sure that every time you create a file in that directory, it gets like that. And the cool thing is, when you run that, you can say, just duplicate what that other directory did over here, and I'm done. You don't even need to know what it means. You just say, well, this is the default. I want to put it over here. Just do everything you did over there, and you're done. And then when you run restorecon or fix files, it will automatically copy those. But notice that I can do that for logins and users. So basically, there's an SELinux user definition, and there's a system user definition. It will try to relate to say which one punches what. It's kind of like between our shadow, I mean, we can basically have a username and an ID map, and if that's it won't, you not really care what you call it and all that stuff. So it maps them in, so it has that definition that says what is the context of the issue. So it's set by default, it's unconfined. And the user created is not confined to SELinux context. If you're setting up kiosk mode, then most likely will not be what you want. Right? We have ports. So when we have, let's say we have port definition for, let's do this, because we have that come up. And make it a little bit bigger. So let's do this again. Just want to make sure. I'm going to use that. Right. So as you can see here, the port definition says that anything marked as HTTP port T has this long list of allowed port numbers that process can open. And if I do not know why you would need to open a UDP port, but I guess it's allowed to open a UDP port for 80 and 4. If for some reason, let's say I want to have it listed on 7777, I got service doing that. If I try to run that as an HTTP process, it will be denied because it's not in the list. All I have to do is use the SE management add and say, to this name, add a TCP port for 7777, and it's allowed. Or if you are more panicky about security, go that I will not allow that. This is virtual on the list. Then you remove something else that are unlisted. That's it. Again, it's just a matter of labels. So once you've told it what labels are associated with what ports, or vice versa, what ports are associated with what labels, you can either allow a function or disallow a function on that.
Is there a, I don't know, I was going to say, is there some sort of functionality within the labels themselves, within the label systems themselves, to have some sort of comment with the labels? So, like, because you may not know what a label means.
GitOps. GitOps, no, there are no comments in there. It's like IP tables or NF tables.
I think that'd be a good feature, but, you know,
Well,
the label have a little bit of metadata.
So what I do, I'll show in a moment what the files are. There are source files with this. And you can put all the comments in there that you want. It won't care. And that's often typical. That's why I said GitOps. So when you define, let's say you're defining how to create a new system and you have custom stuff, that file that has your custom policies would have those comments in it. But once they're installed, they're not there. This is not for documentation purposes. We certainly don't want to put things in the kernel memory that is just a comment. And it's big enough as it is. And some people are very good at making very long comments. There are man pages that will tell you a lot about each of these features and how they are. But as I will go in and show you in a moment, when we create these things, we can make comments in there if we want to. And if you're pulling them down as a GitOps or just a script, shell script, whatever you're using, then your comments, of course, will be ignored as when it creates it, but you can see in the code what it is it's going to be doing. Let's do the other one. So there's a lot here, right? But if you're a regular expression person, you will go, that looks easy. If not, you may look at those guys there and say, what the hell is that? Why do I have all those little parentheses and all that stuff? You will learn that without explaining regex, this simply means anything that starts with this and has as many layers or levels down will be matching. So anything that you create in this directory and all the way down, all the files in there will have that label. That's it. That's all it means. If you don't do that, it is literally only like here. It's only that file that gets the context. Well, other than that, it is, as you can see, I'm going to tell you a little bit about what he interpreted as, whether it's just a single file or not, and all that stuff. But regex helps you a little bit because you know the dot is a wildcard for a single character. Asterisk is a wildcard for any character of any length, including 0. So it's, and the question mark means option. So when you have a question mark right after 2 parentheses, it means this one doesn't have to be there. But if there is something, it has to match what's inside the parentheses, which means everything. Yeah. So all I have to do if I want to have another directory is to add entries to this, do a restore con, and I'm done. You look like you have a question.
No.
Yeah.
No.
No? Okay.
No question.
No question. Okay. So as you can see, we have, so the cool thing is, I think I have a slide dig on that later, a slide on that. All of them more or less follow the same syntax. -L means list what's in there. -A, that's add. -C, delete. -n, modify. And once you have that, you know your context, it's pretty simple commands to do. One that I did not know about until I did this, so I learn every day, and that's is the last one. So there is a way where you can tell SELinux, do not audit, which means don't write anywhere what you're doing. And I have a hard time thinking about the use case, except if your SELinux is going bananas and sending out messages left and right in a second. At that point, you may want to stop it temporarily until you fix the problem and then get it back online. But that is literally, I read the instructions we have for troubleshooting SELinux. One of the things they point out is if you're not seeing what's going on, we may have this. That's been customers calling up, going, I don't know what's going on.
That's one of my pet peeves when they use a negative as an option, because then you have to disable don't audit, which is a lot of Boolean negative not math.
I make fun of the OpenShift engineers every freaking time I meet them, but there's so many double negatives in there that I
Like, please tell me about what that you can't.
You have a Boolean, and if the thing is disable this feature, like instead of is this feature enabled, right? So disable.
Yeah, it shouldn't be don't audit. It should be audit disabled, right? Or something like that.
Yeah, it's already enabled, and that's the default yes, right? Yeah.
Always drives me nuts.
Yep, I agree.
Same thing in code.
Right. Other commands other than the SE manage is the set SE bool. So you saw the again. So this is like chconf. I can temporarily change certain settings just to make sure that things work. I can toggle it, which is like true to false if I know that, and you can just get them. I can do the same with policies. We'll get to those in a moment. I'll even show you a way to avoid having to remember those commands. But SE policy is, if you go far enough back in rel history, that was the command you had to know in order to customize policies. Still there, you can still do it by hand. We will do a little bit of a shortcut to that. And the last little link, again, this is a Jack at JM Walsh, right? So there is a web page that is still out. Last week it was still out. If you go to it,
I'm on it now.
yep.
Because it's just.
This was literally why I think Dan Walsh and back then Thomas Cameron had a ton of talks on SELinux, because that was if you went to a forum and they got in just to save it, right? And they go. My answer to that is, if you disable that, why not switch my 777? You don't care. I have security at all. If it's in a source you want, go ahead. Right? The cool thing is for me, at least in the last 10 releases of or whatever, I've never had to go in and fix it like that. When it has complained, it's a bug, which is either a policy error that was made by the developer because they overlooked something, or it's because I did something stupid and it tried to do and didn't know what I was all like. It wasn't where I had to figure out what policy should really be allowed. But it can happen. Sometimes we do things we don't know. But yes, stop disabling SELinux has been around for a long time, and it's just a matter of run your system in enforced mode on regular things. When you debug, yeah, we may need to do things. But in a moment, I'll show you how to actually disable it completely and remove it. And if we don't do that, we're going to have it.
I disagree with the do not use set and force.
You do? Well, I see your chart, but
Yeah, set and force one straight.
yeah.
Wow.
Yeah.
Oh, you knew it was coming.
Yeah.
Yeah.
I thought it was a coincidence.
Yeah.
No,
Permissive mode.
Yeah.
Permissive mode is what set enforce 0 will give you. And as I said, there is a situation where you need it, because if you need to basically create a new rule based on all your violations, that's the only, you just say, don't stop my process, let it run until I see, but that's in test. It should not be in production. Right. Yes, sir.
It's also a quick way to know if it's something SELinux related that's causing your denial or something else.
I'll get to a moment where you can, the moment there's one error, I can
You
know.
just don't want to set and force 0. Set and force 0 is bad. Set and force 1 is good.
Right, but if you're
Set enforce 1 is implied.
if you're seeing a problem and then you set and force 0 and it works suddenly after that, you know there's something with SELinux.
You can sort of do that, but at that point, it may be too late to damage whatever that code tried to do is done.
So Peter, let's say you have I have my own server, I'm self-hosting stuff. I got a bunch of stuff running on it. Heck, I forget half the stuff that I install on it. But it's terrible. But it's my own server, so I don't have myself to blame for anything to break. All right, so I install SELinux. Should I run audit for 3 months to make sure I catch everything before,
No,
rules and turning it on?
by default, it will audit. If you will have an error message.
But if something doesn't do something during the time in which it's audited, it won't.
You'll get an error that says this didn't work. Your log files will tell you that this was denied by keep saying OpenShift. Sorry, that's my day job. But it will say that it was denied due to SELinux.
I mean, you run a Pi-hole, right? We talked
But
about Same thing, right? You can't go to a website, so you go whitelisted.
But when you see that, you can go and say, well, I can see why that error happened. It should be allowed. And you know that you've been running it for months, so it's really not something you expect there to be other errors.
Yeah.
But if it's a new piece of code that does it, and you go, well, I don't really know what else it used to do. That's why I said that's what it said in the false zero will do, and then you get all the errors. But by default, there is information in there in the order block that something happened and why it did it. So it will say that this process tried to group with this context, tried to go to this file with this context, and the policy denied that access.
What's the overhead on SELinux?
It's kernel enforcement. So as far as I remember,
Minimal.
it's not the minimum. It's pretty much not there.
Okay, yeah.
It's a binary tree lookup that the kernel does into that policy. When I show you how to compile policy, which I'm doing in just a moment when the demo starts, you will notice it takes quite a while, even for small policies. Because it gets compressed all into these little.
So the quant guy is doing stock trading, at the microsecond decision level. They're going to turn on.
They may, so there might be other reasons for doing that, but everything on your box has an overhead. Your file system has an overhead. At some level, you need to figure out what is considered your computer doing stuff versus an overhead, right? But yes, that could be a reason. But once things are loaded in memory, Linux is not involved. It's only when you do something with a kernel that requires escalated privileges, typically. Or you try to open a file that you haven't opened before. It goes, should you be allowed to do that? So, yeah, we did that. Okay, so here we go with where do we figure out how things are configured? The main configuration file is in SELinux, and it's called config. Right? Everything else is going on config files we have. That's a lot. So it's a very small file that basically says what is the default startup mode of SELinux. It can do a few other things, but that's the main part of it. So this is what tells the system when it boots whether you use the enforcing mode or permissive mode. It does not disable SELinux. It just tells it whether it needs to stop you or not. So we can change the configuration file and to allow permissive mode. And then you go, okay, I see what's happened. I need to relabel my system. I did a restore from take and you put in all the wrong SELinux context. For some reason, I didn't back out my extended attributes, which SELinux says, so the whole thing got screwed. Fix file is ungroup. This is what you want to do. This is one of those commands I call get the cover command. Basically, it will send a little flag on the root of your file system, or if there's something, I can't remember exactly what it's called. I use fix files all the time. Something about relabel, but I can't remember the exact name. But fix file sets that when you reboot and it sees that file, the upstart will go to the whole structure of the file system and relabel things based on policy. If you have a file server with millions of pictures, whatever, this is one of those things that will not come up in the next couple of minutes, probably not in the next 10 minutes. It will just basically just sit there and say relabeling files. And so it's a good thing if you have a complete going, what the hell happened here? Like, that will make your system 100% the same as what the policies are saying you used to be.
I missed what you were saying before is like to relabel the whole file system. It's just touch/dot all the way right.
It is root and
That's all you got. And then when you reboot, it'll see that.
Yeah. Oh yeah. Sorry. Yes. Yeah. It sets it. It's like the false FCK file, right? Like you can put in to say, I want to do a file check on process before everything's mounted correct.
Yeah, just to something to encourage me. So because this is at the kernel level, kernel modules are going to be able to get around it.
Nope.
Okay, so you'd have to so you could set
the code that literally runs when you say open this file is what calls and basic calls out through run is it. Now, if you can make your own kernel, yeah, you can bypass.
I'm just saying. Well, I mean, let's say I have a got to get a proprietary kernel block that I want to run. maybe an NVIDIA driver. And, you know, and I don't trust it, you know, I don't trust it. I don't.
This is why we talk about tainted kernels, right? Because if we don't know the code, technically they can reinvent what is elsewhere in the kernel, right? This is the problem. You allow people to make things in your kernel, you're living life a little bit dangerous. They're a little bit better. If there's still a lot of binaries in there, but
And
yes.
not to go on a tangent, but you know, you talk about tainted kernel. I mean, the OpenZFS stuff is all that you know that warrants that it's tainted kernel. But of course, that's all CDDL, you know, source code. So
Yeah.
just because the two licenses are incompatible with one another, but
But
we can see that.
Yeah.
We can actually see it.
anything that you allow to load in the kernel potentially could be opened, right? We do have checks and balances, and this is why we have some yelling and screaming in the kernels now and then, right? Because that's what they do. But I'm looking around this room, some of us are what I call radios. We have way too many of my type of radios in there. We need more people who's going to do this. And from reading what those maintainers have seen, those who want to do it don't have to keep it. So I don't know how to solve that. We need nobody in there.
So we need rest of the kernel.
Yeah. But it's like it's getting dangerous to the point where it's an old fox thing. But anyway, the last command, if you really have a good reason, and let's say you want to have 1 microcentury faster response times or whatever the overhead is, as soon as you grab your command that will show up there, will remove it from the next. Basically, it will no longer be actually. And this is it's still active. This takes it out. But what that means is that every time you create a file or you modify a file, the SELinux context on that file will go away or be modified or not be set at all. So if you come back 2 months later and then change that 0 to a 1 and you try to reboot, you're going to find a message system. It's really not. You can put it in permissive mode and think that's all you need to do so you can see the log files. We still have some problems, but at least it will enforce and rename things correctly. So please don't do that. But anyway, so we talked about here. So here's how we get errors and figure out. The difference between how SELinux reports errors and pretty much every other process is where it does it. And I think this is what picks up some people. I did not question that we have an audit trail in as part of the Linux. Right? We have an audit log that is completely separate from the normal logs, where we're supposed to record security events. User logged-in, password issues, whatever. But it goes into a special log file that no one but you have access to. These days, we've even blocked message from normal user access. Right? So it's getting better, but the log files that normally was there if they would have security information, that is considered a security breach. So they were put in log audit, and that's where SELinux belongs. But it also means that unless you're root, you're not going to see those messages. To get access to those files, you have, typically just use sudo funnel, and you can see those things. That can be blocked, and you can get some other stuff. But the way you can look at them is to use the AU search command. Or I guess if you use that, you use the search. But it allows you to do is to create a pattern of what kind of message you want. And what I typically do is not that long path. I just use the ABC, which is where the label that most SELinux messages will have. And it will go through and tell me everything in the log that it finds either. I can say only for today, for instance, the last 2 hours. And it will show me all the messages that I get. And I can even go and say, only want the ones with errors. As you can see, I can go in and just say, this is going to be SELinux errors, nothing else. And sometimes I really want to see all the real ones so I can see what the relationship is. What has it done? What is it trying to do beyond that? So that's how you want to get out of it. If you want to get explanations, because then I will show you what that looks like. Most people go, that is a weird format. So let's see if we can. I'm going to do something I will not recommend anyone doing, but this is a demo system. It's a VM that is going to be destroyed when I get home. Right, so we have in here, if I do a cat audit, that's the kind of contents we have in here. And let's see if we have any ABCs in here. Oh, I forgot to do that. I'm getting old. Yeah. And I need to push the white button too. Yeah. So right now I don't. This is a machine I built last night and haven't really done anything on it yet. We'll have that in a moment. But these are the typical way things are formatted in here. You can actually see there is a subject, there is an SELinux context here on this one too. And this is the format they will use to report an error. But this is why we have the SELinux troubleshoot command, because it will explain those errors in 2 or 3 pages long, blah, blah, blah text. And it's, why it's doing it, what you can do to remove it or make it allowable, or whether you should consider not allowing it, whatever. And if it finds that, hey, this is a typical boolean thing, it will say this boolean command will allow this to happen too. Finally, we have a interesting little thing on a D message that allows you to go in and get messages from it. Because some of these audit commands will end up in the kernel. So if you get type 1300 or 1400, it will also show you things that are in the case. I don't know a lot of people that do that, but it is possible to do that. So, and in a moment, we'll have some errors that we can look at, right? So the first thing we want to do debugging on the Red Hat systems is to install the policy core utilities Python. That gives us a bunch of cool little tools to make things easy. There's one I forgot to add up there, which is the troubleshoot the dash server. If you have a new install and you install it as a server, as a minimum, you will not have that by default. But it's there to help you understand the message, not there to enable SMS. Those two together should be enough for you to basically do everything I'm showing in a second. The cool thing about SELinux as SE troubleshoot is, as a normal user that has no clue about SELinux, you get a nice little pop-up with a human message saying, and you will deny access to something. And it will try to explain that to the troubleshoot just by clicking on the notification bar. You don't need to know anything about it. Now, if I don't have admin rights, I don't want to do it. I have to have admin rights to see it. When you have a problem, if you do not want to use this, the fixed files option, restore con is the command to do to go in and read the policies and set all the files that you're giving as a parameter. So if you're adding a new path and you need to change all the policies in that from that path, that's the kind of command that you do. And finally, if you say, what the heck is responsible for setting this context on these files, you can use the match pattern condition, and it will look at the path and go to a reverse search in the policy to say that pattern. This is the pattern expression that matches this, and that allows you to figure out where do you need to go in the modify policy in the system. So we'll get to this in a second. Yeah, we talked about showing that, so I'm not going to go into this. So here's the first example. I'll have the files to show you what this is. Right. This is as old school as it gets. If you ever took an exam in World 6 or something like that, this is what you were supposed to know. I would still say it's a good thing to know how to do this, but you've got help to fix this. Right. So basically, to set up a file, it's a text file, it has a policy file called something.te. And I can basically say, allow this process label access to this label on the item, the Apache log, using the That's the policy. Remember, everything that I don't put in here is denied unless it's a policy somewhere else that allows it. And because of that package we did up there, you see the SELinux policy did package. This make command will compile that policy code and make it ready, and you can then install it by yourself. You don't have to remember the commands anymore. All you have to do is that make command. And to me, that's the easy part. Just remembering that at an exam time, or if you're on site and you're doing a production outage, remembering exactly what you have to do for type can be a little bit tough. But you need to look at some command pictures. Once it's compiled, you get a little file that I think is called .pp, and you activate basically reading into the kernel by SE module install and then launch. And it will read that file, that compiled file, rebuild the tree. So that one takes a while to run. But at that point, once it comes back, it's not enforced. That's, normally we create policies that are a little longer than 1 line, but it's the same process regardless of how long they are. So let's take a look at the demo. I think I put it in here. Nope. So let's go back to the demo or SELinux. There we go. Okay. So I'm going to have to cheat a little bit because my memory is not what it used to be. Okay, come on. No. Okay. So in this directory here, so as you can see here, I had the text file. I guess I deleted that, sorry. So I have a small program, and it is extremely small. You do not have to understand C to know what this does. It's a stupid program. It doesn't really do much. But if in case this is hieroglyphs, this is a program that keeps running, and every 5 seconds, it tries to open dialog messages in write mode. Now, remember, in the olden days, that file was pretty damn important. No longer the case. You do not, most modern installs, at least if you have a full enables a system D or journal D, there will be no dialog messages file out of the box. It does not need it. It's all in journal logs, and by default, we no longer duplicate the journal and the text files. It's just a small little change if you want to do that. But I've gotten used to what I can do with journal D that is very hard to do in text files, so I kind of prefer that. But you may not like that. But anyway, so there's no harm in running this, but just in case, this is a demo system. Nothing else is running on this one, right? So I have a piece of code that is silly, but it tries to do stuff it's not supposed to be allowed to do. And right now I'm a normal user, right? There's build daemon white, yep. Go. And I get a whole little binary out of that. And again, it is not that hard to compile a program like that, right? It's pretty simple. So now that I clear that, let me set up a service and then basically take you through how do we take this and create a policy so this will be allowed. So I am going to go to this guy here and cheat. The first thing I'm going to do is one of the symbols. See if I can remember. Okay, I know what's going on. Sorry about that. It's because I'm trying to move to a place where it doesn't want to go.
Oh, is that your computer? It
Yeah.
sounds like it's coming from over there.
Well, that's
It's water dripping, can't you?
Yeah.
hear it?
Like nobody's touching their laptop, and I was like, what the heck?
I just do that.
I'll go with my planner.
Yeah, okay.
I did it with my mouth. It was really good.
That's a little eat.
I always got my volume turned all the way down, so I don't hear that.
But if you don't make mistakes, you'll never hear it.
That's right. I make
Okay.
mistakes.
I-
I usually with the backspace key.
I was doing that. My engineer at work, he wanted to get into the laptop. He said the delete key doesn't work on his laptop.
Use Control H.
Don't make any mistakes. You'll never have to delete. He's on a Windows machine.
Well, there's a burn
That's his
problem.
own problem.
Well, that's what was issued. That's what was issued to him. So, you know, you can't help it.
Wow, that was fun.
That's why I quit. Every time I turned on my computer, it was like,
Okay.
we're doing updates. Or warning, there's nothing wrong with your computer notification.
So the
on the top
problem
right.
is, on a Windows machine, if you delete, kind of hard to unlock the machine.
We're using Microsoft Teams.
Yeah.
Okay.
Configuration option components disabled.
Okay, so this is really, this should not have been taking this long. Sorry about that.
It's not a thing.
So what this basically did was I created a service.
This doesn't do anything by the phone. I had to enable it.
So
Unless you
Maybe
do
it's
this,
a door.
then you have to make sure.
It's a door thing or something.
Well, if you're gonna enable it, you should have it like with a wave file system, like dummy, you know, just a.
So we have a service now. It's all disabled, but I don't really care about having one in boot. But ignoring line. So did I do something wrong with
You had the exclamation point, that's the last line on there.
it? Did it sure did?
We were gonna say something, but we thought we'd let say.
Uh-huh. You're kind of good friends, aren't you?
That's not up to you.
It's
It's a control. Yeah, if I control this. So it might be the distro.
Yeah, it might be the desktop actually. I'd say like KDE.
Okay.
Oh, that's good.
Yeah, KDE 5. 6 is the latest version of it. This is an
Okay. Now, no. Okay.
actual.
Yeah, yeah.
I don't know a stick.
Now, so we have a nice little weird program here.
Yeah.
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 Onwards to the demo.
Yep. Onwards to the demo.
There we are.
10 minutes.
10 minutes. Oh. 13. That's 13. Yeah.
So as you can see here, when we run, it's running unconfined. Remember what I said? If I don't do anything other than that, and the file didn't exist, I can do whatever I damn please. So let's say that what I want to do is SELinux enable this program and start having some fun. I know. My fingers still have screen commands in them. I keep hitting Control A instead of Control P. I need to change that. So now we have a nice little command called SELinux or SEPolicy generate, which we did not have in the olden days. So this will look at the executable and it will figure out what kind of things do I need in my policy to make this work and generate all the SELinux content that I need, to install it and set it up.
So if you were to run A/B search right now, what would it show?
Right now, it doesn't show because the file didn't exist. It created itself unlabeled. But it will, in a moment, once I install this, it will go out and complain and say, well, basically, it will stop the daemon from running because it tries to do stuff it's not allowed to do. So we now have a bunch of files, right? We actually have this little guy called mydaemon.sh. Oh, yeah, I'm not root anymore. Which is actually going to be responsible for doing this install that I need to do. So let me go back here to make sure that's what I need to do. Yes, sir. Come on, dumb fingers. So as you can see, it generates the package. It's not very big. It now installs the policy as the last command. That is the command that takes the longest time. So it created my policy, and it now makes sure that everything is labeled correctly. And what I could do now is to basically make sure that everything has a restore con on them. Because now that I have my labels and everything else defined, I can do that. Okay. So we can now restart and do this stuff. I should have remembered this by heart, but I didn't. Oh, that won't work. I know. So it's not run. Well, now it tells me I have to. Should no longer be running. At least do the. No, I'm in here. Sorry. So here we go. Now we have our actual messages. Wow, this is running in permissive mode. It shouldn't. Nope, it's not. Nope. Nope, there we go. It's denied. Sorry, I looked at my stuff. Okay, I kept looking at the last one. Right, so it's telling me, now that I have a label, I have made this non-unconfined. It is actually now confined. I don't have access. So let's figure out what we can do with that. About that. So I ran this guy. Let's look at the SE alert thing to show what that actually illustrates. Oops, one command. This is definitely the slowest keyboard I've ever been on. So, and the guy in front of it is the key for that. So this is what the alert now looks like. So it comes in and gives us a nice breakdown of that. This is the raw message that is in the log file. And this is literally how it tells me what I need to do. So what it figures out is, well, there's no rule, any easy button. So it tells me all I have to do is to run the order to allow, which is basically taking all the error messages, generates a policy, and then it goes in and says, install a policy. That is the default. If it doesn't know the program, it doesn't really match anything, it will say, look at all the error messages, make them into an audit file, and that's what order to allow does, and install that. And then whatever I try to do right now, what's going to be allowed. It also breaks down that message into all of this data to say, this is where it came from. This is what it was trying to access. And, well, as you can see, it's in target enforcing mode, and this is why it blocked it. So what can we do to fix it? So we can do the order to allow command that it told us about, right? I don't know what I did, but let me try again. There we go. Now that is a kind of small little thing that comes out. It basically says if it's this type, it's going to be allowed to go to the log. Basically what you see down here though is this is a macro. So let me see if it actually created the the source file. I should have created that. Oh, we'll see that in the instructions. Right. So it created a macro, so we can use the macro expander to see what actually that does. And if I can figure out how to use the mouse, it will work. And so we've all seen macros before. It's just basically saying when I see that, this is what I'm going to put in there. So to make our policy work, I'm going to add that to my policy file. Let me first. There we go. So that's what the policy is that it generated. And all I'm going to do is I'm going to add the, probably should be, well, that's funny. You put bash in front of it.
Got mod 777.
Uh-huh.
A plus R goes
Or even really so we've really.
He's running this group.
You should really take a look at the shit too.
What's that?
You okay? Don't care right now. I don't have the root password in this box.
Let me start.
Yep. So let's do it again.
Let me start.
Copy paste. Okay, so we now have them added. We have the log generic. And that means we can now compile it all as pretty short. We just need to do the make. Want to be sure. Yep, let's do again. I'm all the way to root, so who cares? And that one again. I don't know if you guys noticed, but right after I did the policy, it actually expanded the man page with the policy, the group that I had just made, so I can do a man for it and see what security-wise it does. So we should be able to do a system security restart. Yeah. And we shouldn't see it is started, and we're not getting any kind of stopped or anything else. And do you see that? The U search. So unfortunately, when I do this, I figured this one out. Reason is not within a couple of minutes. So I did come up with a command.
That's it. That was after the. That was before these, right?
That was before the restart, right? So I will show you those. And I thought I had put in here. Oops. Stop that. Nope. So I thought I had it in here that it will literally show the last 5 minutes, and I can't remember what that was, the command, but
The comment there says use hour, minute, instead of reason.
let's try to do that. So that was what I did. I didn't make the command then.
Good job.
Good job.
Architect.
Yeah. Oh, that's so that'll be 11.
That's a type 11:27.
There we go. Yeah.
Okay, 11:27. Yeah, do 11:27. There we go.
Yeah. Oh, no denial.
Because you restart the service at 11:20.
Yep. Okay. Anyway, before we did this, you had to go through and create policies. You had to like go through different stages and knowing how to install it. What I wanted to show, even though I kind of was a little clumsy here, is that that make file is all that is needed to basically take an existing binary and have it analyze it and come up with a policy. Once you have that running, as you saw, we might need to add a little bit more because writing to that file is kind of not something a normal process would need to do. We added that to the policy, and now it's allowed to run. Granted, all it does is make an empty file. It's not doing anything funny, but it is accessing a file. So we created a context for the process. We created a context, and we took an existing file, but an existing context, and allowed that process access to that. Those are the main steps that needs to be done. So I know we are sort of way out of it. So this is the last part. So I showed you the SE manage, and it has all of these different commands. You will notice that they all more or less take the same parameters. So -L shows you all the context for the files. -L for ports shows you all the context for the ports. Some of them you can't really add, or you can only modify, but that's pretty much the only difference. They're all the same, right? So if you want to know what is the port numbers allowed for, let's say, HA proxy, it's pretty darn simple to go and do a grab of that. The rules, the user context. So I'm not going to say this is easy peasy and you can just do it, but it is no harder than normal security that we have. Like if you've ever written your own ham files, you know it's not just something you sit down and do without having any preparation. Once you get used to doing it, what the commands are, it will tell you exactly what went wrong. And it's now your job to decide whether that was should be allowed or should not be allowed. So it can either be that alarm bell that says we are seeing stuff that shouldn't happen. How do we respond? Or we made a bug, we need to fix that.
One thing that I try to do whenever I have to create a policy file, a lot of times we're creating those policy files using AU search and generate policy because something is new and nobody's written that's context for it yet. Yep. Is if I notice that SELinux gets updated, that's part of the patching. I will delete my policy out and see if the new SELinux policy supports the new service because a written policy is always going to be better than a generated policy. Yep. And if my service crashes again and doesn't work because of ABC errors, I'll put it back in, right? But I keep removing it, trying, put it back in, just because if you really want good protection, you're going to go with the created policy instead of the generated policy.
And normal best practice is also you need to see what files changed during the update and do some validation of that. I mean, now we're going down some areas that might need some better tooling, but if you just take the updates for granted that they just did it without investigating them, you can't really blame anyone else with the customer. Anyway, so that's pretty much it. SELinux is one of those projects that has 1 billion man pages. I'm just warning you, if you go and say man SELinux, it is basically going to give you a master index of everything SELinux. And those often have subpages too. It is a very comprehensive piece that simplified is what we just talked about today. So I didn't ask before we started, but I should have, is how do you secure your home servers? You kind of said that you didn't. But
I mean, I care, but it depends on the, what it is. If it's something that's safe behind my LAN, I don't really care. But I do have some public servers that I'm a lot more diligent.
you know what the biggest threat from my service is? My stupidity of hitting the wrong keys, as you just saw plenty of examples on. I'd much rather have something that tells me I'm an idiot and gets in the way sometimes when it shouldn't, than something that just does everything as if I knew what I was doing all the time. Like that wasn't a comment where it shouldn't be, or a space where it shouldn't be, or something else. That to me is worth the thing. And also knowing, to my customers, I know big organizations in general who's been saved, by having this and stuff that they thought was already secure. And now, granted, I don't run web servers anymore. But I run something on Plex and other things, and yes, they're all behind walls of different levels of security, including container security. But I don't trust anything I run by default. I want to be sure that if I run a program that claims to be a file server, that is all it is allowed to do. It doesn't have to be this granular. I don't necessarily want to have to block it, but if it shouldn't have access to anything but a local directory, I think that is worthwhile having that policy there. And at least with a container, that's what I get out of the box, right? That's what the $C does when you do your mount point in the container definition. It literally labels that as for this container only, and that's all that container can see. Okay, and that makes me sleep a little bit better because I run third-party software that I don't have the source for, or don't have the time to read the source. What about you guys? I mean, are everyone here using a Linux distribution that has a SELinux? Nope. Well, that might be part of the reason then. Yep. I've seen AppArmor, but what I don't like about that is it's not really done by the kernel, but something else. So I feel that it's easier to disable than it should be. But it has the same idea, right? Of labeling things.
Yeah. It's usually containers or network isolation is what I do. Like I have a dedicated home automation LAN that doesn't have access to the internet, with the exception of one thing. And that helps because I know like it's not, I can put in, like I have my robot vacuum, right? And it's,
My robot
can't talk.
My robot vacuum is very mad at me because I don't allow it to do a lot of things online.
But yeah.
Anyone else?
I mostly use Platinum. I've been looking a lot at Venlock lately. It's a different security module for Linux. It's basically you can give a process and allow this. So file pass is allowed to touch. Anything outside that you can't touch.
I know for the longest time, I don't know if it's still up or not, but there was, I can't remember his name, there was a way that you could actually go to a website and download a custom hosts file. And it was specifically for like ads and on Google and to like block like sponsored content. And it would direct everything to 0, 0, 0, 0, 0, 0, 0. So that you got nothing.
It's called pie holes.
Yeah.
Yeah. Well, host files are really bad because those ads and tracker lists can get massive. And host files don't compress that and optimize that. Like it literally looks at every single.
My pie hole policy has more than 1,000, a million entries.
You need a DNS server.
And it's just everything.
So, but it is, I've done that to a particular, I have something that blocks me from accessing things because it wants to want to shrink and just send it to something else local. I mean, I must admit, I have this both good and bad relationship to security. I've always joked that my next life, I want to be a security officer because I love the idea of being paid to be paranoid. It's no matter what I have presented, it's always never good enough. Like, it's not enough it's encrypted that way. It needs to be encrypted this way, and it needs to, you can't have the key on it. So, well, at some point, you need a key to get the program to work, unless you want to come in every morning and type in the password so you can access something. But it's like every time you come up with a new idea, it's like shut down because it could potentially be a risk. Right? Even though what they already have is high. Nope, doesn't matter.
It's a tough line to walk, because on one side you go too far and go overboard with it and have it just affect every aspect of your life. And the other side of it, you just kind of let everything go.
Right.
It's, yeah.
I mean, I've worked with organizations where I must admit, I leave very, very happy that they are more paranoid than I am about security. And they challenge to say, we know that that's standard, but we won't allow that feature. For standard old-fashioned reverse proxies to much, by the data they have is, is their business basically. And it may also be a complication about that. So they don't just want it running in the default way. Like they want stuff that can do things that most of us may not even afford of. Which is interesting when they start thinking that, hey, I'm running containers, but I'm going to treat them all as VMs. So I'll manage the whole firewall here on the old-fashioned F5. And I go, it won't work. But let's talk about firewalls, how you can do the real work, the Kubernetes stuff. But it's like, it will start with this long list of things that may not even be in the product today, or in Kubernetes today, because they have stringent rules and what someone else can think of. It's what they're monitoring on the network. And they may even have alarm bells that goes off if they see unencrypted traffic to begin with. Right? They may pretend it goes true, but they get nasty gram if they do. So I appreciate it when it's there, but I'm not sitting back in my home lab and saying, it doesn't matter. I'm behind several nats too. I lock things down, including on my IoT stuff, because I don't try, even the ITs I make myself, there's a lot of those things come with firmware already installed. And even if you try to remove it, it may still be there. So it may just be deactivated. So.
Hard-coded DNS.
Oh, yeah. I switched before COVID, I think I bought a new security camera because the one I had was like 10 plus years old. And I found this thing that I thought, well, for a PTC thing, it was not cheap, but it was not very expensive. So I added it to my network, and I have things like Pi-hole running. And all of a sudden, Pi-hole went bananas. It showed me that it was like 10 requests a second coming in. And I got, granted, I had lots of little things, but that was too much. So my security camera was going in panic mode because it kept trying to go just this Chinese side to report back or whatever I wanted to do. And I blocked all traffic outside the US. Right? And the Pi-hole simply just couldn't keep up. And basically said, well, I can't disable it, so I threw out the camera. Waste of money, but I hate that we have so many things that get from scratch.
Yeah, my two rules of home appliances, I go on a mission, is that it cannot require an internet connection, and it cannot run on batteries. The batteries is like a very hard exception to make for some things, but it's like.
So I have devices that use a C-Wave, and they usually last at least a year on battery.
Yeah, but the more you get, the more often like you have to change back. Like they'll start being out of sync.
That's true, but that's why you make
that's
why you have a little alert that goes in and tells you where any batteries are. But at that point, all you have to do is the first time you change battery, you change some more of them, so they're more or less in sync. But a motion sensor where there's a lot of traffic will run out battery sooner than one that sits in an area where it gets on. So
I'm gonna stop the recording.
Yep. Well, thanks for coming, and I'm pretty sure we're going to have a security topic again. Maybe not at SELinux. So
I would love to see something on eBPF.